Hi dear all, welcome you again to another session of chemistry. Today we are dealing the chapter coordination compounds dear all. Hope you all are fine and we are starting the session dear all, coordination compounds. I think we completed around 5-6 chapters from chemistry. Now we have only few chapters left. Dear all, February 28th, don't forget the date, chemistry exam. It should be very easy. We are hopefully presenting all the important MCQ from the same chapters. So today we are dealing with which one? Coordination compounds. Dear all, just begin with the most important concepts once again. Let us just recover all the concepts once again from the chapter coordination compounds. Okay. So dear all, coordination compound chapter, which all area you have to be focused more? That is first one, IUPAC nomenclature. IUPAC nomenclature based MCQ question, even 1 mark descriptive type of question we can expect dear all. MCQ, aqua, amine, carbonyl, nitrosyl, like many ligands and metal atom, how to present their name. Maybe name to structure or structure to name, that we can expect dear all, just like IUPAC of coordination compounds and organic compounds, same like that. You know the rules, everything. And so IUPAC nomenclature is a most important question from MCQ. Second one, for overall coordination compound chapter, IUPAC, first one. Second one, we can expect question from what is the oxidation state calculation, oxidation number calculation, coordination number calculation, right? Or how to calculate the oxidation state, how to calculate the coordination number, etc. And which all the types of ligand dear all, monodentate, bidentate, polydentate, ambidentate, chelating ligand, different type of ligands are there. And we have to expect some question from valence bond theory, which is the first theory in the chapter dear all, Werner's theory, right? Werner's theory expected questions, VBT, valence bond theory, very sure question, crystal field theory, and the spectrochemical series dear all. Spectrochemical series, various ligands are arranged according to their crystal field splitting, right? So the strong ligand, which all are weak ligand, it's compulsory to know the spectrochemical series dear all from the chapter coordination compound. And after that, we can expect a very important MCQ or very important 1 to 2 mark question from the isomerism part dear all. Structural isomers are there, stereo isomers are there, different types are there, optical isomerism, geometrical isomerism, and ionization, coordinate, linkage, right? Hydrate, make many isomerisms are there. I hope you all are ready with all content with you. So let me check it, how many of you prepared the chapter thoroughly or not. And dear all, we can expect question from the stability of coordination complexes, and the last part is there, some application of coordination compound, that's also important, like cisplatin, some anti-cancer treatment, some and hardness of water, how to check, those all areas also important dear all. So let me check it, how many of you prepared the chapter thoroughly, and please be ready with your book, pen, etc. So are you ready dear all? Shall we start? Now time is 9:04. Shall we start? Those who are in online, can you please respond dear all? Are you ready to crack the questions from coordination compounds? Kaushik, ready? Shall we start? Dear all, this is for your upcoming exam. Aditi, Reshma, Dhruvil, Ebin. So hope you all are ready. Samuel, Azim, all right. So dear all, here is the first question. Albert, all right. Here is the first question for you. Let's start with a simplest question dear all. Tell me dear all, what is the answer for this question? This question is very simple. What is the number of ions given by this given complex? Total how many ions can be produced by this complex dear all? Tell me dear all, how many ions that you can prepare from this coordination complex? Just split into the cation and anion. Tell me, how many ions? How many ions can given by this compound? Yes, answers are ready. Answers are ready with you. Very good dear all. Dear all, this complex is just like a compound AB4. Just like AB4, right? It's an ionic compound. Coordination compounds are ionic one. There will be a cation and anionic part. So AB4, when you split, what you will get dear all? A4 plus and 4B minus. Yes or no? You know this 4 come from this cation, 1 come from this which one? Anion. So you will get 1A and 4B. Total how many ions are there? 5 ions are there. So dear all, let me split this compound dear all. PT NH3 6 time O charge 4 plus and 4 Cl minus. 4 chlorine as a counter ion. Dear all, total how many ions? 1 plus 4, total 5 ions are given by this compound here all. So what is the answer? Option C, 5. I think most of them are given the correct answer. There is no wrong options, no answers, right? Yes, all are correct. So dear all, let me tell you, based on this number of ion, we can expect one more question. Let me tell you. My aim is not just to answer this question, what all type of question we can expect more about the same concept. Dear all, based on the number of ion, we can expect one more type question. What is that? They will give you around 4 compounds A, B, C, D, and they ask you which one can make more ionic conductivity. Which one can make more electricity? Which one conduct more electricity? So dear all, remember this point, the one which can give more number of ions, the one which can give more number of ions can conduct more electricity. Remember all of you, as if the complex can give more number of ions, it can produce more electricity. Just keep that point in your mind. You can expect a question regarding number of ions. Okay, so let's go for question number 2 dear all. Tell me, when 1 mole of each of the following complexes treated with the excess of AgNO3, which will give maximum amount of AgCl. Another simplest question. I hope you can able to answer the correct one. Yes dear all, sure, there is no doubt, there is no doubt, should not be any doubt. Okay, so keep practicing, all of you, keep practicing and keep giving your answer. Immediately we should strike, we should get the concept immediately and try to apply that concept into the question and crack it. So dear all, first this compound, let me tell you, this complex when split, what you will get? You will get CONH3 6 time 3 plus and 3 Cl minus, right? Similarly, you can able to see there are here 3 chlorine outside, here 2 chlorine outside as a counter ion, and here only 1 chlorine. You know, counter ions can undergo complete reaction. When you treat these complexes with AgNO3, you will get AgCl. If you treat the first compound with AgNO3, you will get 3 AgCl. Why? Because there are 3 chlorine outside as counter ion. All those 3 chlorine can undergo reaction with the silver nitrate. It will give you 3 AgCl. Same way, if you treat the second compound here all, it will give you 2 AgCl. Because there are 2 chlorine outside as counter ion. What about this one? It will give you only 1 AgCl because there is only 1 chlorine outside. Dear all, and the last compound do not give any AgCl precipitate because there is no chlorine as a counter ion. So dear all, whatever be the counter ion, it can undergo complete ionization. So it will give you the product as precipitate AgCl. They are treating with the excess of AgNO3, so you will get which one? AgCl as a precipitate. So which one can give maximum amount of AgCl? That's nothing but that is option A. Who given the correct answer first? Yeah. Again, I want to just confirm that. What's your name? That fake flick flop. What's your name actually? Okay, Sohail, thank you. Fadi, okay. All right, okay, Fadi. It's okay. So dear all, so this is the way we have to answer this question. So number of ions, how to write the number of ions, that is very important. Okay, so whatever the number of chlorine outside, every chlorine can undergo which one? Reaction with the AgNO3, it will give you 3 AgCl. This is the one maximum. Option A is the answer. Alright, so dear all, let's go for the third question. Dear all, arrange the following complexes in the increasing order of their conductivity. This is the question which I said in the first part. Dear all, conductivity related to number of ions. If it can give more number of ion, it can make more conductivity. Can you tell me, dear all, which one can make more conductivity among this one? Tell me, dear all, among 1, 2, 3, 4 compound, which can make more ions? Which one can make more conductivity? Can you tell me? Can you tell me, dear all, from the 1, 2, 3, 4 compound, which one can make more conductivity? More conductivity. Which one? Which one? Third one? Third one? Yes. Why third one, dear all? Because there are 3 chlorine outside, right? All of them can undergo. So, dear all, this complex, when they split, you will get the complex with the charge 3 plus and 3 Cl minus, which means total you will get 4 ions. If the first compound undergo dissociation, you know, coordination sphere or coordination entity won't split. Coordination sphere or coordination entity won't undergo dissociation. So it won't break. What about this compound, dear all? If this compound split, you will get the compound charge, the sphere charge plus Cl minus. It will give you 2 ions. What about this one? The complex with the charge 2 plus and 2 Cl minus. You will get 3 ions. So dear all, the third one giving more number of ions, the one which can give more number of ion, it can conduct more electricity or conductivity. So third one, then fourth, second, first. Third one, fourth one, that's only one option. Option A is the correct answer. All are correct, right? All are given the correct answer. Dear all, so try to understand the point mainly. The one which can give more number of ions, it can conduct more electricity. That's it. Okay, let's go for the next question. According to Werner's theory, a easy question, statement wise question also we can expect, dear all. Statement wise question we can expect. Total 3 theories we had discussed in this chapter: Werner's theory, valence bond theory and crystal field theory. According to Werner's theory, which is correct among this option? Tell me. Tell me, dear all. According to Werner's theory, which option is correct? And one more thing, be careful, dear all. Whether they are asking the correct answer or wrong answer. Very careful. Means whether they are asking correct statement or wrong statement. Very careful. Okay, so here they are asking which is correct. Let me tell you, dear all, according to Werner's theory, the central metal atom possesses 2 type of valencies, right? 2 type of valency. What are they? Primary valency and secondary valency. When I am saying this concept, I know that, I hope you are saying the answers very fast. Means when I start, according to Werner's theory, there are 2 type of valency. Then you are saying in your mind, yeah, primary valency and secondary valency. That what I need. So dear all, revise everything very careful. Primary valency is there, secondary valency is there. You know, primary valency give you the oxidation state of the metal, whereas secondary valency give you the coordination number of the complex, right? Whereas primary valency is what we call ionizable valency, whereas secondary valency what? Non-ionizable valency. That's it. So dear all, according to Werner's theory, there are 2 type of valency: primary valency and secondary valency. Primary valency give you the oxidation state, secondary valency give you the coordination number. Primary valency is also called ionizable valency, secondary valency is the non-ionizable valency. So what is the correct answer, dear all? No doubt, option A, primary valency is ionizable. Secondary valency is not ionizable. Primary and secondary valency are ionizable. Wrong. Neither primary nor secondary valency ionizable. D. Dear all. So from coordination chapter, statement wise questions also we can expect. So let's I will show you some more question regarding statement. Okay. So all are correct one. Primary valency is ions and secondary valency is the coordination number. Yeah, primary valency give you the oxidation state, secondary valency gives the coordination number. Let's go for the next question, dear all. Question number 5 for you. Here the question, I'm waiting for 5 seconds. Give the answers and read the question carefully. Ammonia acts as a very good ligand what about ammonium ion? What is ammonium ion? NH4 plus. Why ammonia is the best ligand whereas ammonium is weak or less? Tell me, dear all. Ammonia acts as a very good ligand, but ammonium ion does not form complexes because. Albert, starting with Albert, Reshma. Aditi, okay, Dhruvil. Who is this Lord of Biology? Okay, all are given correct answer, dear all. Option A, amine is a gas while ammonium ion is in liquid form. Is it a reason? No. Ammonia undergo sp3 hybridization and ammonium ion. Hybridization is not a factor. Ammonium ion does not have any lone pair of electron. Yes. Dear all, what is a ligand? A ligand is a negatively charged or neutral charged species have an ability to donate electron to the metal. Ligands are giving electron to the metal and they are making a coordinated bond. You know very well. So dear all, how it can act as a species, how it can act as a ligand? It should have an ability to donate lone pair or electrons, right? So ammonia, you know, ammonia, we call it as amine. Amine, why it is a ligand? Because it have an ability to donate the lone pair to the metal and then they can make a coordinated bond. Whereas in ammonium ion, it doesn't contain electron to donate. It cannot act as a ligand. So answer is which one? Option C. There is no doubt. Oh, sorry. Okay. All right, fine. All right. So that's the answer is what? Question number 5. Answer is C, dear all. Let's go for the next question. Question number 6. The ligand is. They will give you a unknown ligand and they will ask you what is the denticity of the ligand, whether it is monodentate, bidentate, tridentate, tetradentate, hexadentate, like that. So they are given a ligand here. What is the denticity of the ligand? Come on, all of you. What is the denticity of the ligand? If they given a unknown ligand, don't worry, there is a simple method to identify what is the denticity of a ligand. Let me just expand this compound here all. N with what? CH2, CH2, NH2, like 3 times, right? CH2, CH2, NH2 here, and here we have CH2, CH2, and then NH2. This is the compound and this is the ligand given. What is the denticity of the ligand, or how many donor atoms are there? That's a question. How many donor atoms are there? Come on, all of you. How many donor atoms? How many donor atoms? They're all, this nitrogen carry a lone pair. This nitrogen carry lone pair. There is a lone pair. There is a lone pair, dear all. You can easily able to understand what is the denticity of a ligand if there is a lone pair or negative charge site. What? If there is a lone pair or negatively charged site, they are donating one. They are donating site. So dear all, he can donate electron to the metal. He can donate electron to the metal, and this and this. Total there are 4 donation site, and it's called what? Tetradentate ligand. Tetradentate ligand. What is answer? Option C is the correct answer. Yes. What do you mean by denticity? It is a type of descriptive question for exam. Okay. What do you mean by denticity of a ligand? It's a number of donor atoms. Right. So what is the denticity of this ligand? 4. Tetradentate ligand. Right. Can you tell me, dear all? You may studied EDTA, right? EDTA, ethylene diamine tetraacetate. What is the denticity of EDTA? What is the denticity of EDTA? What is the denticity of EDTA? Yes, we studied. It's a hexadentate ligand because there are total 6 sites to attack. 6 sites to attack, dear all. Hexadentate ligand. EDTA is a what? Hexadentate ligand. Keep in mind, all of you. Let's go for the next question. Come on, all of you. Come on, all of you. Coordination chapter. You should give the answer immediately. Before the explanation, you should give the answer immediately. That's what I need. Among the following, which are ambidentate ligand? Come on, all of you. Which all are ambidentate ligand from the following? Which all are ambidentate ligands? Come on. Which all are ambidentate ligands here? Which all are ambidentate ligands in this one? Careful, okay? Careful, okay? Don't make mistake. Don't make mistake. Today is what? 15th. Only few days are there for our exam, so don't make any confusion with the topics, dear all. Dear all, we have total 3 sets of which one? Ambidentate ligand. Which all are? Cyanide is there, isocyanide is there, it's 1 pair. Thiocyanate is there, isothiocyanate is there, another pair. Nitrito N is there, nitrito O is there, it's another pair. These all are ambidentate ligand. You can expect a statement question for your board exam. What are ambidentate ligand, dear all? What are ambidentate ligand? They are actually some monodentate ligand have an ability to donate. There are actually two donor atom, but at a time they use only one, right? So dear all, SCN, yes, it is an ambidentate ligand. Nitrate, very careful all of you. NO3 is what? Nitrate, nitrato. It is a monodentate ligand, not a ambidentate ligand. What about NO2 minus? NO2 minus is what? Nitrito-N. Its ambidentate ligand is what? Nitrito-O. Yes, it's an ambidentate ligand. But what is this C2O4 2 minus, dear all? Oxalato. It is a bidentate ligand, not a ambidentate ligand. 1 and 3 are ambidentate ligand. Option A is the correct answer. Ambidentate is two attacking site. Yes, they have two attacking site, but at a time they use only one. That's an ambidentate ligand. So ambidentate ligands are actually which type of ligand, dear all? Ambidentate ligands are generally monodentate ligands. Monodentate ligands, right? Okay, so answer is option A. Let us go to question number 8, dear all. Tell me which of the following ligand form chelate. Tell me, dear all. Which of the following can make chelate or chelation? Chelation. Which of the following ligand form a chelate or chelation? What are chelate, dear all? What are chelate or chelating ligands? Come on. They are actually bidentate or polydentate ligands, right? Yes or no, dear all? What? Chelating ligands are actually bidentate or polydentate ligand. Bidentate or polydentate ligand, they have an ability to form ring structure with the metal, and you know chelation makes stability more. Chelation makes stability more. This point all of you keep in mind during the discussion. Finally, I will give you a question and I will say the same point here. What is the point? Chelation makes more stability. So dear all, chelation is formed by either bidentate or polydentate ligand. So the question is simple. Which is a bidentate or polydentate ligand given the following? You know, acetate. What is acetate, dear all? CH3COO minus. You know, it's a monodentate ligand, right? What is oxalate? C2O4 2 minus. You know, it's a bidentate ligand. Cyanide, it's a monodentate and ambidentate ligand. Ammonia, amine, it's a just monodentate ligand. So dear all, among this four option, which is the only one bidentate? That is only option B. You know a list of bidentate ligand, maximum or majority we studied only two bidentate ligand in this chapter, right? Which all oxalate and EN. What is EN? Ethylene diamine or ethane 1,2-diamine. That's the only two main bidentate ligand we had discussed in this chapter. So yes, Azim, yeah, bi or di means bidentate or polydentate ligands have an ability to form what? Ring structure with the metal. That what we call, yes, ring structure around center metal atom. CO is more stable than chelate ligands. That's a case of which one I'm saying about. Normally if they given monodentate ligand and this chelating ligands, in these cases mostly they will ask you that point, which all they will give you monodentate ligand some complexes, chelating ligand some complexes. In such cases chelation makes more stability. Not with the CO, mostly they will ask that question. I'll show you that question at the end. Okay dear all, let's go to question number 9. This is related to the charge of the ligand. Easy question, but don't make mistake. Which of the following not a neutral ligand? Come on all of you. Which of the following not a neutral ligand? Come on. Which is the answer? Which is the answer? Which is not a neutral ligand? Which is not a neutral ligand from the following? Come on all of you, which is not a neutral ligand? You know H2O, aqua, charge is 0. Amine, what is the charge? Amine charge is also 0. What about ONO? What is ONO? Nitrito-O. You know, its charge is -1. And what is CO? Carbonyl, right? Carbonyl ligand also neutral ligand. Its charge is what? 0. So which is not a neutral ligand? Option C, ONO is the charge. ONO is the charge. Option C is the correct answer. I'm just writing two ligands here. I'm just writing two ligands here. Tell me what is the charge of those two ligands immediately. Okay, just write first letter or first number comma the other one. I'll give you two ligands. Tell me the charge immediately, all of you. What is the charge of sulfato and ethylene diamine? Immediately. What is the charge of these two ligands? Sulfato and the En. What is the charge? Yes, sulfato charge is what, dear all? Good, -2, and En is a neutral ligand, right? 2 and 0. Dear all, compulsory to know. It's very compulsory to know the charges of the ligand, because it is needed for your valence bond theory, it is needed for your oxidation number calculation, etc. All are given. Correct answer, yes, SO4 charge is -2, ethylene diamine charge is 0. Right? Okay, next question, dear all. Question number 10. Which of the following ligand will not show chelation? Come on. Come on, all of you. Which of the following will not show chelation? They are asking you which is not a bidentate ligand. Which is not a bidentate ligand or polydentate ligand? That they are asking. Come on, all of you. Which of the following do not show chelation? Chelation is made by, they're all bidentate or polydentate ligand. So which is not a bidentate ligand here? That's the answer. Careful, all of you, don't make mistake. I think there is one option that's not a familiar compound to you, right? EDTA, you know, it's a polydentate ligand. He can make chelation. Not our answer. What is DMG? They're all dimethyl glyoxime is called what? DMG, dimethyl. A structure is like this one. There is 2 methyl group with NOH is called which one? Even though if you don't know the structure of DMG, this answer is easy one. So this is what called DMG, dear all. DMG also there is a bidentate position. Okay. So what about ethane 1,2-diamine? You know that is also a bidentate ligand. But SCN minus thiocyanate, it is a monodentate ligand or ambidentate ligand. He cannot make 2 bonds at a time because its denticity is what? 1, right? You can consider it as a monodentate ligand or ambidentate ligand. Anyway, it is not a bidentate or polydentate ligand. So what is our answer? Option D. He cannot make ring with the metal. So answer is what? Option D. Yes, option D is the correct answer. So dear all, question number 11 for you. Tell me dear all, immediately calculate. Even the oxidation state, everything you calculated many times. Even mind itself you can able to answer what is the oxidation state and coordination number. Come on fast. What is the oxidation state and coordination number for this given complex? Come on. What is the coordination number? So very careful of you. What's they're asking? Coordination number and then oxidation state. Come on. What is the coordination number and oxidation state of the given complex, dear all? The metal atom is given E. Any metal. So what is the coordination number? Hafiz, Adia? Okay, Sana, Kushik. Okay, that's starting with 11th one. What, there is any confusion? Sorry, A. Okay, now it's correct. Okay, fine. So dear all, let me calculate the coordination number first. What is coordination number? It is the number of sigma bond around the metal. E is the metal. It is connected with what? En twice. 1 En, you know, it can give 2 sigma bond. So 2 En which can give 4 sigma bond. And what is that outside? What is that another? You know, C2O4, that is what? Oxalate. It also gives 2 sigma bond. So total how many sigma bonds are there? 1, 2, 3, 4, 5, 6. Yes, coordination number is what? 6. Coordination number 6. So we can cancel the option C and D, because they're starting with the 4. And what is the oxidation state? The element E oxidation state, we don't know directly, right? Take it X. En is a neutral ligand, charge is 0. 1 oxalate charge is -2, and NO2 charge is -1. Overall it's a neutral compound, so the sum is 0. So what is X dear all? +3. So coordination number 6, oxidation state 3. What is answer? 6, 3. That is option A. Anyone given wrong answer? Dear all, if you make a mistake during this discussion, not an issue, because our aim is on the board examination, should not make any mistakes. So our answer should be sharp. Don't be overconfident also. That's also one of the biggest point. Don't be overconfident. I know everything. Okay? If I studied, yes, am I able to do or not? If you focusing one question, if you answering one question, just to focus. That is the only one question you're focusing now. So my aim is to get the correct answer from that. You don't need to bother about question number 4 if you're answering out of the 14 MCQ. If you're answering 4th question, don't be afraid about that. I have to answer 10 more question. No, when you're answering one question, make it fast and yes, this is my question. I want to get marks. So your aim should be on that particular question. No need to bother about other chapter or other questions. Okay, concentrate on that. So question number 12, let's go for that. This is a statement question. Identify the statement which is wrong, which is not correct. Read all of you, give a correct answer. Which statement is wrong? Which statement is wrong? Which statement is wrong? Come on everyone. Which statement is wrong? Okay, very carefully read the options all, because we don't want any specific question, any answer from that, from the 4. It should be a correct answer to get marks. Dear all, option A, coordination compounds are mainly known for transition metal. Yes, that you studied in D and F block chapter. Why coordination complexes are mainly formed by transition metals? Because it shows variable oxidation state, etc. You must study. Coordination number and oxidation state of a metal are same. It's not compulsory coordination number and oxidation state are same, right? It can be different. So option B is the answer. Yes, already we got it, right? Option C is possible or not? A ligand donate at least one electron pair to the metal atom to form a bond. Yes, of course, that is a ligand. And this complex is a heteroleptic complex. Heteroleptic complex means that it contains different types of ligand. Yes, it contains amine, chlorine. Yes, different types of ligand. That's a homoleptic complex. Here all, option B, that is the wrong statement and is our correct answer. Yes, correct. Here all, I think the question which we discussed up to 12, most of them are given correct answer. There is no wrong options or wrong answers given. Keep going all of you. Question number 13, what is the correct IUPAC? IUPAC related one question definitely we can expect, okay? What is the correct IUPAC name of the compound? And if the option is not there, you just inform me. What is the correct IUPAC name of this compound? All of you work out on the question. And Fadi, what happened? You said homoleptic, it's not. Yeah, homoleptic means what? Homoleptic means the one which contains same type of ligand. Heteroleptic means it contains different type of ligand. It is heteroleptic, right? Yeah, it is a correct one. Yeah, homoleptic means they contain same type of ligand. Heteroleptic contain different type of ligand. All right, yes. Okay, what is the answer, dear all? Question number 13. What is the correct IUPAC name of this given complex? What is IUPAC name of this given complex? Dear all, here cationic part is potassium and the coordination part is which one? The complex is there. So here potassium. Yeah, let's start here all. Its name is what? Potassium. Cyanido is there. Nitrosyl is there. Cyano or cyanido. And what is NO, dear all? Nitrosyl. Alphabetical order is what? Cyanide is first, right? So pentacyano or cyanido. What is this NO? Nitrosyl. Who is the metal? Iron, where iron is in the anionic part. So what we write? Ferrate, right? Ferrate. What is the oxidation state of iron in this question, dear all? 3 potassium charge, 3. Fe charge, let's calculate. CN charge is -1, 5 cyanide -5, nitrosyl is a neutral ligand and overall charge is 0. X is equal to what, dear all? +2. So 2 here, and is there any counter ion? No counter ion. Counter ion is there? Yeah, it's already in the beginning part, right? Like the right side, it's not there. Already cationic part is potassium, anionic part is which one? The complex. All right. So what is answer? That is option A. Anyone given? Option A. Yes. Option A is the correct answer, dear all. Potassium pentacyano nitrosyl ferrate 2. Nitrosyl, that's a name, okay? NO is what we call nitrosyl. What is CO? We call carbonyl. NO, nitrosyl. Careful, okay? Option A. Let's go for the next question. This is the just opposite. What is the correct formula of this complex? Here name is given, write the structure. Come on, all of you. Tell me which complex is suitable for the given name. Come on. Speed up all of you. What is the correct name of, and name is already given here. What is the correct structure of this given compound? Come on, all of you. What is the correct structure or the formula of this complex? One answer is ready. Second answer, third answer, fourth answer. Fifth. I think this time is enough to get this question. Speed up. What dear all? B, C, A. Maximum they will give you only 4 options, okay? Don't expect one more option A, B, C, D, E. Don't say one question different many options. I think for this question only I am getting A, B, C, 3 options. Anyone is there to say option D? Then all options almost over. Okay, so dear all, let me check it whether answer is there or not. Tetraamine. What is tetraamine? NH3 4 time. Okay. Tetraamine. Chloro. What is chloro? Chlorine Cl. Nitro. What is nitro? NO2, or sometimes we will call what? Nitrito N. Platinum. What is the metal? PT. And counter ion as sulfate. Okay. Total the charge of the platinum is 4. Let's see, is it 4 or not? Platinum X. Amine charge 0. 1 chlorine charge -1, NO2 charge -1, sulfate charge -2. Overall it's neutral. Yes, dear all, it's already +4. So you don't need to make any change in the counter ion number. So dear all, which is the correct answer? Which is the correct answer? Sample paper. Okay, Anshika, it is there in the sample paper. Definitely there is certain question pattern from chemistry, dear, so you don't need to worry. Okay, just try to answer. So is it option which one? Nitrosyl as stable, carbonyl. Nitrosyl, carbonyl. Carbonyl is the one which can make more. Which one? Carbonyl is the one which can make synergic bond. It make more stability. Yes, which is answer? Option C, right? PT NH3 4 time, Cl NO2 SO4, right? Option C. Dear all, it is not compulsory to give the ligand in the alphabetical order, okay? You don't expect the ligands in the sphere, they will give you as per the which one alphabetical order. They will give in shuffled manner. You know the naming rule. Okay, fine. Let's go for question number 15, dear all. Now time is 9:39, dear all. Only 20 minutes left. Let's crack many questions. Which among the following will be named as? Repetition, come on. Which one named as dibromido bis, ethylene diamine, chromium 3 bromide? Tell me, which is the correct answer? Which is the correct answer? Which is the correct answer? Adin? No. If they given NO2, it will be nitro or nitrito N mostly. NO2 nitro or nitrito N. They're all dibromido. Most of them are given the correct answer. Dibromido, which means Br2. Bis ethane 1,2 diamine. En twice. Chromium is the metal Cr, and the counter ion is bromide. They're all as per this formula. What is the charge of chromium? Chromium X. 2 bromine charge -2. En is neutral ligand. 1 bromine, now I consider here, so minus 1, overall neutral, we will get X equal to plus 3. Do you want plus 3? Do you want plus 3? Yes, we have plus 3. No need to make any changes. What is the answer given? Option A. CR, twice, BR twice, BR. Yes, option A is the correct answer. Now this one make all correct answer. Yes, option A is the correct answer, dear all. Let's go to the next question. Tell me once again, what is the name of the compound? Reverse question. Here structure is given. What is the IUPAC name? Come on, don't make any mistake. What is the answer? What is the answer? What is the answer? Alright. What is the answer, dear all? What is the correct IUPAC name? Pentaamine, nitro or nitrito N, cobalt. I think the oxidation state is 3 and outside you have chloride. What is that answer? Option C. Pentaamine, nitro, cobalt, oxidation state 3 and outside you have chloride. Option C is the correct answer. Dear all, we can expect a question regarding IUPAC name. Careful and don't make mistake. All are given correct answers. Sana, Didi, Angeline, Deva, Nidin, Adin, Abin, Advait. Right, all are given correct answer. Good, all of you. Keep going. Tell me, dear all, let's enter into the isomerism part. Which of the following will not show geometrical isomerism? Most expecting MCQ from the chapter regarding the isomerism part. Most sure. Which of the following will not show geometrical isomerism? Let me tell you, dear all, geometrical isomerism, that is nothing but our cis-trans isomerism, mainly given by 2 complexes. Which all? One is square planar complex and other one is octahedral complex. Careful, all of you, careful. Dear all, tetrahedral complexes do not form geometrical isomerism. You know the reason, the bond angles all are same. Where geometrical isomerism is mainly given by square planar and octahedral complex. In square planar complex, the type which is giving Ma2B2, the type Ma2B2 can give this, which one? Cis-trans isomerism. Whereas in octahedral complexes with the type Ma2B4 type, they can give cis-trans isomerism. And there is another type, you know, Ma3B3, it will give you FAC and mer isomer, right? Facial and meridian. Dear all, the first complex, it is a type Ma2B4. Yes, he can give cis-trans. This type is also Ma2B4 because you know it is a bidentate ligand. 2 are there, so it will give total 4 side and that is Cl2. What about this type, dear all? C is a type Ma5B. The C option is the type Ma5B. Such a type cannot show cis-trans isomerism. Option C is the correct answer. Which type is this, dear all? Ma2B2. Yes, he can give. Our answer is which one? Option C. Option C is the correct answer, right? Option C. All are given the correct answer or not? Dear all, the isomerism is a most sure question, okay? Please careful. Okay, let me give you the next question, dear all. Which of the following complex species is not expected to exhibit optical isomerism? Which one cannot give optical isomerism? Let me give you a clue for that. In order to show optical isomerism, they should contain En twice or En thrice. Means 2 or 3 same bidentate ligand. Or OX twice or OX thrice. This is one of the condition, okay? This should be there in the compound. That's not enough, and the mirror image should be non-superimposable. In such cases, it can show optical isomerism. So, which one cannot show optical isomerism? Means what, dear all? It contain En2, it contain En3, it contain En2, it doesn't contain any bidentate ligand. Dear all, option D cannot show optical isomerism. In order to show optical isomerism, dear all, please keep this point in your mind. In order to give optical isomerism, that it should contain 2 or 3 same bidentate ligand and their mirror image should be non-superimposable. That's the main condition, okay? Ashika, which one cannot give optical isomerism? In order to give optical isomerism, Either En twice, En thrice should be there, or OX twice, OX thrice, mean 2 or 3 same bidentate ligand should be there, and also their mirror image should be non-superimposable. That such a cases it can show optical isomerism. Here you see such a ligand is not there, it cannot show that. Okay, clear? Next, dear all, which of the following compound exhibit linkage isomerism? Come on, all of you. Linkage isomerism, you know the best condition what? It should contain a ambidentate ligand. Come on, all of you. Come on, all of you. Which one can give a linkage isomerism? The one which contain, which one? Ambidentate ligand. Come on, all of you. Which one contain ambidentate ligand? Which one contain ambidentate ligand? Which one contain ambidentate ligand, dear all? In the first compound it is not there. Second compound is a coordination isomerism. Option C contain NO2. NO2, its ambidentate ligand is which one? ONO, right? ONO. It can give what? Linkage isomerism. Most expecting question, linkage isomerism. Okay, remember, if there is an ambidentate ligand, it have an ability to form which one? Linkage isomerism. Next one, which of the following isomer will give white precipitate with barium chloride, dear all? Come on, easy question. Which one can give a which when you treated with a barium chloride solution, which one can give a white precipitate? Come on, all of you. Yes, I mean we are using AMM, I mean AMM. Come on, all of you. Question number, be serious about the question, all of you. Question number 20, which of the following can give a white precipitate, dear all? No doubt option B. When you treat the option B compound with a barium chloride, when you treated this compound with a barium chloride, dear all, it will give you barium sulfate, it's white precipitate. Remember, all of you, barium sulfate is white precipitate. Yes, it will give you option B. Okay, yes, okay, all right, fine. Question number 21, all of you go fast. Now time is 9:47, speed up. Few isomers are given below. Mark the correct statement regarding them. You can able to see 1, 2, 3 compound. Which one can give, or what type of isomerism is this? What type of isomerism? What type of isomerism? Fadi, yes, AGBR. AGBR is yellow color. AGBR is yellow color. Tell me, dear all, few isomers are given. What type of isomerism given by this complex, dear all? 1, 2, 3 are hydrate isomerism. What do you mean by hydrate or solvate isomerism? Same molecular formula but different number of water as ligand. Here you see there are 6 water as ligand, 4 water as ligand, 3 water as ligand. Same formula but different number of water as ligand. What we call hydrate or solvate isomerism. Yes, dear all, answer is what? Option A. Dear all, let's speed up. Mark the incorrect statement. Come on, all of you, speed up. Don't make a mistake, okay? Don't make a mistake, dear all. Don't make mistake. Which one is a correct, incorrect statement? Incorrect. Come on. Inner orbital complexes are D2sp3. Yes or no? Yes. Outer orbital complexes are sp3d2. Yes or no? Yes. Tetrahedral complexes generally dsp2. Do you agree with that statement? Dear all, tetrahedral, if you studied VBT, don't make mistake. You know, tetrahedral complexes mean sp3 hybridization. dsp2 means what? Square planar. Square planar. C is the wrong option, means wrong statement. That is our correct answer. Option C. Option C. Alright. So next one, dear all. This complex is related to our VBT. Let me do the question. In my case, if you able to answer very fast, you can comment in the chat box. Please wait, okay? Dear all, we have 3 steps to calculate the shape and hybridization, etc. according to VBT. What is step 1? Step 1 is write the ground state of the metal, cobalt. Cobalt atomic number 27, dear all. So we will write argon 18, 4s2, 3d7. What is step 2? Step 2 is the excited state. Here cobalt is 3 plus oxidation state. Let me lose 2 electron from here, 1 electron from here. What is the left? 3d6 and 4s0. What is step 3? Step 3 is identify the ligand. The ligand is fluorine. You know halogens are weak ligand. Pairing won't happen. So d6, how you can write here all? If there is no pairing, you can write like this one. 1, 2, 3, 4, 5, 6. This is 3D, this is 4s. Total, 6 ligands are there. If there are 6 ligand in your complex, you should provide 6 vacant orbital. So let me take after 4s, 4p is free. After 4p, 4d is also free. So dear all, let me take 6 orbital. 1, 2, 3, 4, 5, 6. What is hybridization? Yes, p3d2. Octahedral. And is it diamagnetic or paramagnetic here all? It is highly paramagnetic because they contain many unpaired electron, and sp3d2 diamagnetic. Which answer? Which answer dear all? Which answer? Which answer? It is paramagnetic and sp3d2. Option A, right? Option A. Option A. That is the correct answer. Good all of you. VBT. VBT. Next question. What is the magnitude of the magnetic moment? Magnetic moment nu is equal to root of n into n plus 2. The unit is what? Per magneton for the given complex NiCl4 2 minus. Dear all, what is n in the magnetic moment equation? Number of unpaired electron. That you find first. What is the central atom here? Nickel. Nickel atomic number 28. So we can write argon with a 4s2 3d8. In this complex, nickel is in 2 plus charge. 2 plus mean lose this 2 electron, 3d8 left. And chlorine, halogens are weak ligand. This 8 electron won't undergo pairing. So you will get electron 1, 2, 3, 4, 5, 6, 7, 8. So tell me dear all, total how many unpaired electron here? 1, 2. N value is equal to 2. Substitute in this equation. When n is equal to 2, what is nu? Root of 2 into 2 plus 2, that's equal to root 8. Root 9 is 3, so root 8 is close to 3. Which one? 2 point something. That is option A. Option A. Magnetic moment. No, magnetic moment we can expect dear all from the D and F block portion also we can expect the same type. Okay, so careful. Atomic number, yeah, mostly they will give atomic number, but not sure, means up to atomic number 30 we should remember. At least atomic number up to 30 compulsory to remember. Okay, careful all of you. Tell me dear all, which of the following complexes will show maximum paramagnetism? Maximum paramagnetism means the one which contain maximum unpaired electron. Dear all, D4. 3d4 means 4 electron. 1, 2, 3, 4. It contains 4 unpaired electron. 3d5 which means 1, 2, 3, 4, 5. 5 unpaired electron. 3d6, what do you mean by 3d6 dear all? 1, 2, 3, 4, 5, 6. That contain 4 unpaired electron. What about 3d7? 3d7 means we can fill 1, 2, 3, 4, 5, 6, 7. There is only 3 unpaired electron. Which one contain maximum number of unpaired electron? That can give maximum which one? Paramagnetism. No doubt that is option B. Right? Option B. Yes, Sohail, you can type in the chat box, I'll clear it. So this is the, they're all higher paramagnetism means highest number of unpaired electron. They're all 6 minutes left. Let's go for the next question. Electronic configuration of this one on the basis of crystal field splitting theory is, dear all, it is an octahedral complex. In octahedral complex, you know which way they're splitting, T2G and EG. Come on fast all of you. Copper is the metal, atomic number 29, that is argon with 4s2 3d9. In this complex, I think cobalt charge you will get 2 plus, right? So sorry, copper. So copper 2 plus mean lose this 2 electron. What is left? 3d9. And the ligand is amine. Amine is a strong ligand. So this 9 electrons undergo pairing, right? This 9 electrons undergo pairing. After pairing, what is the situation, dear all? 9 electrons if it paired. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you split into which level, dear all? T2G and EG. You know, T2G is the first 3 orbital where 2 are there. This is our T2G orbital and this is our EG orbital where it contains 2 and 1. So tell me, dear all, total how many electrons are in T2G and EG? T2G contain 6 electrons and EG contain 3 electrons. So what is our answer? That is option T2G 6 and EG 3. Option B is the correct answer. Option B is the correct answer. Yes. So dear all, based on which theory? It is related to the crystal field theory. You know, in crystal field theory, the octahedral complex is split into T2G and EG. 3 level below, 2 level above. So very careful. The octahedral splitting is a most expected and important question, dear all. Let's go for the next one. The most expecting question regarding our spectrochemical series. Tell me, dear all, which is the correct order of the ligands according to their crystal field splitting power? Tell me, which one having greatest, which one having greater, or which is the correct order of the spectrochemical series? Correct order, okay, correct order. Question number 27. 27, Fadi. Is it C? Is it C? Sure? Yes, dear all, the highest strength, the ligand is for which one? CO, then cyanide, then amine, then aqua, fluorido, and then chlorido. Yes, option C. Spectrochemical series, dear all, the most expecting part. Please study the entire ligand and their correct order. Correct answer, dear all. Let's go for question number 28. Match the column 1 with column 2. This is from the application part. I'm not going for the answer. Tell me, dear all. Estimation of hardness of water. Tell me, hardness of water we can identify by the help of which one? Whether 1, 2, 3 or 4. Tell me, hardness of water. Hardness of water. My aim is not to get the answer immediately. I want to just clear the concept, all of you. Hardness of water is connected to which one? Hardness of water. Hardness of water. Hardness of water is related to, very good, hardness of water is related to what, dear all? EDTA. And next one, detection and estimation of nickel. Nickel estimation with the which one? Dimethyl glyoxime. You will get a rose red precipitate. And next one, electroplating. Electroplating is what? Potassium dicyanoargentate, and the anti-cancer treatment, you know, cisplatin. So all together, which is the correct answer? A, second one. A, second one. That's only one option. Option B is the correct answer. Dear all, this question is from the application part, okay? Application part of coordination compound is the most expecting part. Please study cisplatin and all. Anshika, the conversion questions, if you have our numbers, you just inform to the, please text to the WhatsApp to the number. I will definitely clear it, okay? Whatever the question you have, just send to me. Definitely I will clear it, don't worry. So next question number 29. Tell me, dear all, both geometrical and optical isomerism given by which complex? Everyone, don't make mistake, give a correct answer, okay? Only 2 minutes left, dear all. Please tell me the answer fast. Both geometrical and optical isomerism. Yes, Sohail. Yes, Sohail. We should be very confident and we should be serious about our examination, dear all. All are here to discuss the maximum most expected question for our upcoming examination. So don't be lazy and keep going and keep giving the answers, right? Which one can give both geometrical and optical isomerism? Any answer? Most of them are given option A as a correct answer. Let me check it here. Option A. There's a cobalt is given. Cobalt is the metal given. How we can draw the shape of this molecule? There is 2 chlorine and En, right? This is the structure. This is the cis form, and if you put 2 chlorine, one above and below, it becomes trans form. Yes, it can show cis and trans. Among this one cis, it is optical isomerism because it contains En twice, and the mirror image will be non-superimposable. Very good, dear all. Option A is the correct answer. Question number 30. What is the correct name of this compound? Dear all, this compound is nothing but cisplatin. This compound is nothing but cisplatin. It is used for anti-cancer treatment. It is used for cancer treatment. So dear all, what is the name of this compound? Diamine dichlorido platinum 2. Very good, dear all. Option A is the correct answer. Cisplatin, its name is what? Diamine dichlorido. Which one? Platinum 2. Dear all, which of the following is the most stable complex? This is the question which I said. Fadi, do you remember? From among this option A, B, C, D, which is the most stable compound? Which is the most stable compound? Yes, Fadi. This is the question which is most stable among this one. Dear all, option A, option C. Option A or C. Option A or C. Dear all, option C which contain a chelation effect, whereas option A contain CO. The one which contains CO, have an ability to form what? Synergic bond. It make more stability. So option A can be that. Option A, carbonyl, yeah, metal carbonyls can make more stability. Which one? Then chelation effect. Okay, chelation is also making which one? But option A can be the most preferred. Dear all, the last question for you. Palladium complexes are given here. What type of isomerism is this? Which type of isomerism? Which type of isomerism can given by these two compound? You can able to see two compounds are with the same formula. What is their difference, or what type of isomerism can it possess? Which type of isomerism? Which type of isomerism, dear all? SCN is there, here NCS is there, thiocyanato and isothiocyanato, which mean it can show linkage isomerism. Linkage isomerism. Option A is the correct one. So dear all, we covered IUPAC part, VBT part, metal carbonyls part, Werner's theory, crystal field theory, the application part. These are the and the isomerism part. I am expecting question mostly from IUPAC and isomerism part. Hope you clear this session and entire questions. Thank you for your good answers. So dear all, thank you again, and those who have doubt, dear all, don't wait. You can get our numbers from the YouTube channel, so please text to the number. Definitely we will be here to clear the entire doubts. So thank you all, thank you once again, and good night all of you. We will meet again with another session with the chemistry within 3-4 days. Thank you all, good night.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.